So the first thing you do is you write down the equation. Make sure you wrote it above the graphing grid, of course, so you have it as a reference for later, like on our quiz, you could use this. I always like thinking about the parent function and the transformations first. In this case, my parent function is just 1/2 to the power of x. Remember, parent function is always just the number to the power of x. Now the plus 1 then is not part of the parent function. Since it's hanging on the end, that means it's been moved up 1. So the entire graph has been moved up 1. Does that move the asymptote? Yes, it does. And so the very first thing you should be doing on your graph is drawing in your asymptote up at 1. Once you have your asymptote drawn, our first point, remember, is always in the same place. It is always up 1 from the asymptote. So make sure that you got your first point now in the right location. All right, now once we plotted that first point, the great part is that I have now used all the transformations. I don't need to worry about those anymore. So I can kind of mentally check those off. All I now need to know is that my parent function is 1/2 to the power of x. What that means is that as I go to the right, I'm multiplying all my heights by 1/2. And notice I say my heights because it's the distance from the point to the asymptote. How far apart are those? So like that first one's up 1, the next one's going to be up 1/2 as far. And so my next point's going to be up 1/2 of that distance. And my next point after that will be up 1/2 of that. And so again, I cut that distance in 1/2. Now, are you going to be absolutely perfect? No, but you should be pretty close. We're looking just here, making sure that you understand the process here, not that you can actually distinguish between 0.2 and 0.25 when plotting a dot. All right, now, that's as we go to the right. We're multiplying by 1/2. So what happens then as I go to the left? It's like dividing by 1/2, but that's kind of weird to think about. Dividing by 1/2 is the same as multiplying by what? 2. And so as we go to the left, in this case, we're going to be multiplying by 2. So my first point here, it's up 1, so my next point will have to be up 2. And then it has to be up 4. So I did 2 times 2 to get 4. I then do 4 times 2 to get 8. I then would be doing 8 times 2, which would be up 16, but that's off my grid, so I don't need to plot it. But it's all a matter of seeing that pattern, seeing that whatever my last one was, that's what I'm multiplying by to know how far to go up next. So like after going up 16, we'd have to go up 32 and so on. Because I'm just multiplying the last height by 2. Now once I've filled in all the points that I can fit on my grid, I go ahead and draw the curve that goes through it. This is our final answer. This is what we are working toward. So having practiced the graphing that we first learned a couple lessons ago, we're now going to jump into some more story problems, some more compounding interest problems. Please write down this information. I'm going to reuse the same information a couple times, so going ahead and taking the time now to write it out is going to help you. All right, so we got it written down. Now we got to look and see how we would do it. Now, there's not just the single formula that we can use here. I can't just go back and plug it into p times 1 plus r to the power of t. I can't quite do that here because, yes, I invest $500 and it's growing by 8%, which already is telling me, yes, go that direction, but I am also investing an additional $500 at the start of every single year. So that's going to change things a little bit. Now, for doing this particular problem, notice it's only 2 years. That's because we're going to have to do this first one by hand. So we're going to do this one out the long way. So I want to know how much will I have at the end of year 1. Okay, this one should be fairly straightforward, right? I'm going to do the 500 times what? What would I multiply 500 by to figure out the year-end amount after just 1 year? 1 + 0.08. Now, we got to multiply it by the percent, right? But remember, I don't just multiply it by the 0.08. I have to still do the 1 plus that. So we're going to multiply it by 1.08. Okay, so now we can go ahead and do that calculation. And so we end up with 540 here. Now, you'll notice I only did this for the first year. I didn't just like do 1.08 to the power of 2 or something, because year 2, I'm not just doing the same thing. In year 2, what is my starting amount in year 2? It's going to actually be the 500 plus the 540, yes, because at the start of the year, I had 540 already in the account. But remember, I'm investing an additional $500 at the start of every year. So at the start of this year, I actually have $1,040. That's why I can't just take the original amount and like square the 1.08, because I wouldn't be investing the additional 500. And so I'm going to do the 1,040 and multiply that now by 1.08 to figure out how much I'm going to have at the end of year 2. And when we do that calculation, we should get $1,123.20. And so notice by actually making ongoing investments, we're going to have our amounts increase even faster, right? And this is a little bit more typical of what we would see in real life. When you start thinking about retirement and stuff like that, you don't make one investment and then just stop investing. Usually, retirement plans involve investing a certain amount every single year, repeatedly. And so today we're looking at what happens when we do that kind of situation. Now for that note, we do have notes. All right, so this is the formula that we use for compounding interest of regular contributions. So I'm contributing some amount over and over and over again. In this case, this one is specifically for a certain contribution at the start of every year. There's also ways that you can manipulate the formula to make it work for like contributing every month and things like that. But it gets even more complicated looking, and I just don't want to worry about that right now. We're just going to worry about annual contributions for the time being. Now, as you take a look at this formula, you wrote it down to your notes. Let's make sure that you wrote it down correctly. Notice the 1 plus r, we're used to seeing that. That's in its own parentheses. That is all to the power of t plus 1. So that t plus 1 is your exponent. The minus r and the minus 1 up here, those are not part of your exponent. If you get confused about what is and isn't part of your exponent here, it's going to give you some trouble. And that whole thing is over r. Now, I've only defined down here one variable. I've told you what c represents. It represents the contribution amount at the start of every year. I haven't told you what a, t, or r are because they're the same things that they've always been. A is your final amount. T is the number of years. R is your rate as a decimal. Okay? And again, you don't need to memorize this formula. Just put it in your notes, and we're going to see how we can apply it. So I want to go back to the same problem that we just looked at before, and I want to actually be able to plug the numbers into the right places into our new formula and get the right numbers out. So we're going to practice using it on the simple little 2-year example, and then we're going to bump things up. So, first up, do I know what A is here? No. A represents the final amount, so it's going to be A of T. Do I know what T is? Yes. T is the number of years. That's going to be 2. So we're going to be looking for what A of 2 equals. Next step in my formula is C. C is the amount that we are repeatedly investing. Our contribution amount is 500. So it's going to be 500 times, now we have a big old fraction here. On the top of the fraction, I'm going to start with 1 plus r. So it's going to be 1 plus r, remember, comes from my percent, but I still have to have it as a decimal. So it's still going to be 0.08. Then that's to the power of t plus 1. Well, t here is 2, so it's going to be 2 plus 1. Then that's minus r. Again, r is still the decimal, so it's going to be 0.08 minus 1. Big fraction bar there. And this is all over r. R is still the decimal, 0.08. End the parentheses. Now, as you take a look at doing this, notice the very last thing you're going to end up doing is actually multiplying it by the 500. You're going to have to figure out what this whole big fraction equals first. Now, within that fraction, we're going to be doing the top first. Now, it looks really big and ugly, right? But the beautiful part about this formula is that proper order of operations pretty much means you're just working left to right. So, a of 2 equals the 500 we're saving for later. Now, into the fraction. What is 1 plus 0.08? That's 1.08. And that's going to be to the power of 2 plus 1. What's 2 plus 1?
3.
Okay, this is tough math here so far, right? And then you might be tempted to go ahead and do the minus 0.08 minus 1 right now, but I'm actually going to save that. It helps avoid one possible error with the negatives in there. So I save that till after I do the cubing. All right, now we can go ahead and do that calculation on the top. We're going to end up doing the 1.08 cubed. Now when I do that 1.08 cubed, I get 1.25972. I don't like writing out big long numbers like that. I find it to be a bit of a pain. So I don't want to have to do that over and over again. So now that I know what that number is, it's currently showing on my calculator. I'm now going to go ahead and do that number, oops, wrong tool, minus the 0.08 and then minus 1 to get what the top of my fraction equals. And so when I do that subtraction, I end up getting 0.179712. It's still a lot of decimals there, but at least I didn't have to write out quite as many times. Now I want to do that division. But the great part about doing the division is you don't have to retype in that big, long, ugly decimal. It's already showing on your calculator because it's the last thing you just did. So on your calculator, you're just going to say that number divided by 0.08. And in this case, that's going to give us 2.2464. Again, I just have that decimal showing up on my calculator, so I don't need to like retype that in or anything like that. So the last thing I do now is I multiply that by 500. And when we do that, do you know what number we're going to get? You should, because it should be the same thing as what we did when we calculated it out by hand. $1,123.20. We're now going to take a look at this problem. Now this one, you notice the setup is exactly the same with one difference. The first time we did it for just 2 years because we could do that one by hand and it wasn't totally ridiculous. If you try to do it for 30 years by hand, it would get quite ridiculous, right? Having to do what is it in year 1, what is it in year 2, what is it in year 3. But now that we know what our formula is, it's actually no harder to do this one than it was the last one with the 2. It's the exact same effort. The only difference is that we're going to be plugging 30 into our formula instead of 2. And again, I got the formula written down there, but it should be in your notes. Just use the same formula from your notes as we do this. Start, please, by just plugging stuff in, and then we'll go from there. All right, so when you plug everything in, this is what we should be looking at as our equation. It should be the exact same equation you wrote for the last problem, except it's a of 30 instead of a of 2, and our exponent is 30 plus 1 instead of 2 plus 1. Everything else is the same that you just wrote in compared to the last one, because notice I gave you the same contribution amount, and we are working at the same rate. So now, you know that your equation was set up right. Now go ahead and do the calculations. Let's make sure we can get the right calculations to come out in the right order. Now, when you do that calculation on the top, many of you are going to find that you can do that calculation kind of in one big flow. So like what I did on my calculator is I did 1.08, because I could do the addition in my head, to the power of 31, because again I can do that addition in my head. And then once I got that number, I subtracted the 0.08 and I subtracted the 1. And that gave me a number that was 9.78 76694. It just keeps on going. I don't want to write down that whole number. I wrote down a shorter version of it just so I can keep track about what it is, and so you can also look and see that your number is about the same when you do that top. But I'm leaving the whole thing on my calculator. I'm not typing it in all from scratch, so that I can then say divide by 0.08. Now when I do that particular calculation, I divide it by the 0.08. We should find that we are multiplying the 500 by a number that it's about 122.35, roughly. Now remember, that's a rounded number. I'm still keeping the entire decimal on my calculator so that I now can multiply it by 500. And so last step, multiply that number by 500. And when you do that, you should get an answer here of $61,172.93.